Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to compose functions. All right, so let's go over the following example, question number 1. So let's say if g of n is equal to negative n to the third plus 2, and h of n is equal to 3n minus 3, the task is to find g composed with h of n. Okay. All right, so the first thing we're going to do is go ahead and write down the formula. What does g circle h of n mean? Well, this simply means that we're going to be composing g with h. Okay, so g is going to be the parent function, and then h of n is going to be the input function that we're going to be plugging into g. Okay, so what we're doing in essence is substituting 3n minus 3 for all the n's in g. To help us stay organized, we're going to start by writing down the parent function. Now, the parent function is the one that's the outer function or the one that comes first. Okay, so this is a parent function. What's happening is we're taking the input and we're plugging it into the parent function. All right, so in order to have something to plug it into, we have to write down the parent function first, so that's going to be g of n equals negative n to the third plus 2. All right, now the input function is going to be taking the spots of the variables, the independent variable to be specific. So what we're going to do first is get the parent function prepped. All right, to make way for the input function, we are going to replace all the n's with parentheses. So the n here, we're going to be substituting it with the name of the input function, h of n. And then on the right side, this n will be replaced by the value of h of n, which is 3n minus 3. Okay, that for a degree binomial. So we have parentheses raised to the third power plus 2. All right. Now let's go ahead and make our substitution. We have g of the input function, which is h of n. Let's make that blue and green. So h of n. And then on the right side, we have negative parentheses. H of n is 3n minus 3. And then we raise that to the third power plus 2. Okay? Now, one mistake that students make is they distribute the power into these two terms here. All right, like that and then like that. That's inaccurate. You don't distribute an exponential value across sums or differences. All right, only product and quotients. So what are we to do next? Well, we're raising this quantity to the third power, so we're going to have 3 copies of 3n minus 3 being multiplied by one another. Okay, so g composed with h of n is negative parentheses 3n minus 3 first, 3n minus 3 second, 3n minus 3 third, plus 2. Okay, so let's go ahead and simplify this. Now, how do you multiply 3 binomials? Well, in order to do this, we're going to attack it 2 at a time. Okay, so I'm going to shift gears. I'll do the work on the right side here, and then we will put the answer back in here. Okay, so what we want to do is we want to find out what 3n times 3n times 3n is. So we'll start by multiplying 3n minus 3 times 3n minus 3. So since we're multiplying 2 binomials, we can just double distribute or FOIL. So you go first, outer, inner, and then last. Okay, so it helps you stay organized while you're multiplying 2 binomials. So when you multiply that out, you have 3n times 3n, that's 9n squared. 3n times negative 3 is negative 9n. Negative 3 times 3n is negative 9n. And then negative 3 times negative 3 is plus 9. Now the middle terms are like terms, first degree variables in terms of n. So we have 9n squared minus 18n plus 9. Okay, now what we're going to do next is we need to multiply it by the third, 3n minus 3. So we can use FOIL here because we're not multiplying two binomials. What we are multiplying is a quadratic trinomial with a binomial. So the methods you want to use, you can either use the box method or you can multiply vertically. I'm going to do the vertical multiplication here. So 3n minus 3. Okay, and let's go ahead and multiply across. All right, so when you're multiplying vertically, it says do your multiplying numbers. Okay, keep track of the columns. The columns are like degree terms. So this is a 0 degree column, first degree, and then second degree column. All right, let's go ahead and multiply. What we'll do is we're going to take this -3 right here, and we'll multiply it by 9, multiply to 9 to -18n, and then to 9n squared. And then when we're done with that, we'll take +3 and multiply it in the same fashion. Okay? All right, let's go ahead and multiply. +9 times -3, or -3 times +9 is -27. -3 times -18, 30 plus 24 is negative, actually minus times minus is plus, so +54n. You see how everything in this column all ends, okay? -3 times 9n squared is -27n squared. That's what happens when you distribute -3 across all these three terms. Next thing we're going to do is multiply 3n across all three terms. 3n times 9 is 27n. Put it in the n degree column. First degree column, 3n times -18 is -54n squared. Well, what's the sign here? We did 3, so plus and plus. This is plus. Okay, and then 3n times 9n to the second power. 3 times 3 is 27. N times n squared is n to the third. So we have 27n to the third. All right. The third degree term doesn't have any columns that fit, so we have to create its own column for it. Now let's go ahead and add downwards. That will give us our product. So when we add downwards, we have 27n to the third. Combine these two, we get minus 81n squared. Combine the n's, 54n plus 27n is 81n minus 27. Okay, so this is what you get when you multiply 3n by itself 3 times. Now let's put it back in here. So g of h of n is now going to be, don't forget the negative, minus 27n to the third minus 81n squared plus 81n minus 27 plus 2. Okay, now we have a minus here. We have to distribute across all terms, so that yields negative 27n to the third plus 81n squared minus 81n plus 27. Okay, and then we have a plus 2 over here. The only like terms that can be combined are the constants, the 0 degree terms. Combine those two, and that will give us our final answer. Negative 27n to the third plus 81n squared minus 81n plus 29. Okay, so that is G composed with H of n. All right, let's go ahead and box our final result. All right, let's take a look at question number 2. In this case, we're going to be evaluating a composed function, okay, at a specific input value. So let's say that, let's say if f of n equals n squared plus 4n, and g of n equals negative 2n plus 3. And the task is to find f composed with g evaluated at the value of 6. Okay? All right, so whenever you're trying to find a composed function evaluated at the value, there are two ways we can go about it, but we're going to focus on the method that involves composition first before evaluation. Okay? So let's break it up into two steps. Part one is you to find the composed function f of g of x, like we did in question number 1. Independent variable here is n, so let's stick to that. We need to find f of g of n first, and then next step is to evaluate f of g of n at the input value of 6. All right, so all this simply means is you plug in 6 into all the variables in the composed function when you've simplified it completely. All right, let's go ahead and do it. So part 1, task is to find the composition of the two functions f of g of n. All right, so first step is to ID and write down the parent function. The function on the outside, or the one that comes first, is f. So we have f of n equals n squared plus 4n. All right. Now what we're going to do is get the function prepped by clearing out the variables and replacing them with parentheses. So we have parentheses and then we have parentheses square plus 4 times the parentheses. Okay, so all your independent variables, namely n, need to be gone. Okay, because we're about to substitute. Now what are we plugging in? We're plugging in g of n and its value. On the left side, plug in the name of the input function, g of n. And on the right side, plug in the value, negative 2n plus 3. And then 4 times negative 2n plus 3 twice. Okay, let's go ahead and simplify that. We have negative 2n plus 3 raised to the second power. So we're going to have 2 copies of negative 2n plus 3 multiplied by each other. So we have negative 2n plus 3 times negative 2n plus 3. Okay, plus, we're going to go ahead and distribute the 4 across these two terms here. When we carry out a distribution, let's see what happens. This positive 4 times negative 2 actually changes the sign because plus times minus is negative. So we have negative 8n plus 4 times plus 3 is plus 12. Okay, now we're going to go ahead and follow this out. Whenever you multiply two binomials, you can accomplish that by multiplying the first, outer, and then inner, and then last. Double distribution, okay? Negative 2n times negative 2n minus times minus is plus, so you have 4n squared. Negative 2n times 3 is minus 6n. And then positive 2n times negative 3 is negative 6n. And then plus 3 times plus 3 is plus 9. And then minus 8n plus 12. All right, now what we're going to do next is just simply combine like terms, okay? So we have 4n squared. We can combine these two terms, minus 6n to give you negative 12n, plus 9 minus 8n plus 12. Okay, let's see what we can do here. Bring down 4n squared. All right, let's focus on the first degree terms, plus 12, negative 12n, minus 8n. Signs are the same, add and keep the sign. I have negative 20n, and then you combine positive 9 and positive 12, plus 9 plus 12 is plus 21. All right, and that is f of g of n. Are we done with the problem? The answer is no. Remember, we have part 2 that has not been addressed yet. In part 2, we're going to be evaluating the function at the input value of 6. Okay, so part 2, we're going to evaluate f of g of 6. Okay, so let's rewrite f of g of n again. F of g of n is equal to 4n squared minus 20n plus 21. So f of g of 6 just simply means that we're plugging in 6 into all the n's in this composite function. All right, so 4 parentheses 6 raised to the second power minus 20 times 6 plus 21. All right, now let's go ahead and reduce that using order of operations. I want to do the exponents first. So 6 squared is 36, 4 times 36. And we can multiply these two to get negative 120 plus 21. 4 times 36 is 120 plus 24, which is 144 minus 120 plus 21. 144 minus 120 is 24. 24 plus 21, your final answer is 45. Okay, so that is f of g of 6. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial helpful in your study of composition of functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.